Hello and a warm welcome to our webinar from Zirkonzahn. My name is Marco. I'm a German MDT and working since 5 years for Zirkonzahn. And I'm really proud to present today our unique digital workflow. And well, I hope you're doing well, also in that sad time. But we are really proud to do also those webinars right now in a digital way over live streams to get closer to our customers or new customers worldwide. Again, a warm welcome to my friends and colleagues and all the interested people worldwide. And we will start in time. You are allowed to to ask any kind of questions. You have a little question icon in your menu bar. You are allowed to ask me any questions during the webinar, and I will take time after the webinar, around 5 minutes, to answer a few questions. If your live stream does not work probably in a proper way, then you have to press F5 to refresh your site, and then everything should work fine. I will start immediately because, in my opinion, what I want to present to you today is quite special and unique and a lot of information, and I don't want to waste time to do the intro right now. Let me share my screen and then we start immediately. Okie dokie. So, as I told you, I want to present to you today the whole digital workflow. And what we can do with this kind of digital workflow. A lot of people, they say, okay, digital workflow is just intraoral scan or our main CAD software, or from other companies, CAD software. But it's more than this. More than this means you are able to receive, with different workflows and different devices, more information up of the patient situation to get a better workflow, or to design your restoration in a proper way. Not to have only a aesthetic, but also a functional result. And for this kind of workflow, we use our special system called Plane System, and a 3D facial scanner called Face Hunter. And what is quite new, it's a device to record the mandible movements. And this device is called Plane Analyzer. And I have also a special part I want to show you. It contains our implant planner as well to create a backward planning. And for that, I have also a nice solution to create an immediate workflow. So, and I prepared for sure some topics, and I want to speak about intraoral scans a little bit more deeper. I have some tips and tricks to do it better. And then we go over to the patient registration, and by using also the facial scanner. And after that, we talk about the Plane Analyzer to record the mandible motions. And after those kind of workflow at the beginning, we start with the designing process, and I will guide you through all those steps and give you tips for special stuff to create the restorations better. And last but not least is then I want to talk about the implant planner. Let's talk about intraoral scans. Everybody, well, most of the people, doctors and technicians, they want to use intraoral scans. A lot of people, they ask myself, what is the best intraoral scanner on earth? Well, I have not a favorite intraoral scanner, when I'm honest, because all the intraoral scanner work almost similar, and they have the same quality, result in the end. You have to pay attention about the costs or the fee yearly, and what is more important is how to how to continue with your designing process, how I can use the intraoral scans in a third-party CAD software or in another software. And this is the most important question of all. We have intraoral scans, they are just closed systems, so they are not able to convert those kind of data in an international format like STL or other data format. They just keep their own closed format, and this is quite difficult for us to work with. Obviously, Zirkonzahn is an open software, an open CAD software. You are able to import at any point a international format like STL, OBJ, or OFF, like those files, and to work with those. And also what we are able to give to you is a kind of import module for several intraoral scan devices like 3M, 3Shape, iTero, and so on. So you are able to use also original intraoral scan data as well. And what is the comparison between original formats and the converted to STL format data? Well, the original formats, they are kind of raw data. They're containing a lot of more information about the scan itself. And the normal or the conventional STL format is it's a converted format with, and I'm pretty sure that we lose a lot of quality or a lot of details that are necessary for our workflow. Of course, you can use STL files, but I'm more a friend to using the original data formats. For example, I'm quite experienced with Carestream scanner, and this scanner is as I can say, is an open scanner. Open scanner means we are able to export those data immediately in STL or PLY format. PLY is nothing else as an STL framework with a texture onto it with colors. Of course, the Carestream scanner can also export those files in a DCM file, a DICOM file, to import them in our software as well. So if you use other scanners, you're able to import via the modules, import modules, and if you're not able to do that, then you have to convert them in STL. The other story is how to detect the implant positions. Well, as you know, we work with the scan flags, scan markers. Zirkonzahn has their own scan markers. Now in total we have 4 different scan flag types. And what you can see here now onto the picture, it's a quite good example. We use for that kind of scan our standard scan flags. Of course, a lot of clients would say now what he's doing right now there, because those kind of scan flags, they are usually just for the model. That means if I want to detect the implant position from a physical model. But if you have space into the patient's mouth, you could actually use those also in a patient's mouth. Well, a combination between scan flags and dies is not a problem at all. And those are the 2 other scan flags I want to talk about. Onto the left side, you can see, our white scan marker. And onto the right side, our white metal scan marker. The white metal scan marker will take over the white scan marker in the future. You are able also to buy right now. The benefit of this, because it's made of, the entire scan flag is made of titanium, and we have a special coating on top to get the intraoral scan read better the surface. And also the screw to tighten or to screw the scan flag onto the implant, it's built into the scan flag and will not go out of the scan flag as well. It's quite comfortable for the doctor to use this. And the 4th type of scan flags is the little pieces you can see under the reconstruction. Those scan flags are called scan analogs. So the scan analogs, they are quite nice because you could use them to screw them in a physical impression onto the impression coping and scan the whole impression with a scanner. And After scanning, we are able to rebuild or produce a positive model of this kind of impression. And with the scan analogs, we're able to detect the implant position by doing that. And the other benefit is to use those scan analogs is, I want to show you later on a bit better, you can use those as implant analogs in a milled or printed model. And I hope a lot of interested people are watching right now, and also doctors, because I have to explain a little bit the problems, currently the problems, especially when you use our workflow. For our workflow, is very, very important that we scan the whole situation of the upper jaw. Not only the teeth part, you have to scan also the whole palate. And if it's possible, also the tuber region where the hamular notch is, because then we could use a special measurement workflow to know in the end the tooth placement. I will explain you and show you later in more details. And also what you can see quite good in this picture is that this scan is made without the scan flag. A lot of people, a lot of technicians and doctors, they don't know that. But for technicians, it's very, very important that we have the whole profile or visible the whole profile, the emergency profile. And if you make just one intraoral scan, and this one intraoral scan has already the scan flag screwed onto the implant, then we are not able to see the whole emergency profile. So please do and try to do in the future two separated scan, one scan just as a gingiva scan with all the gingiva informations, and the second scan will be then the scan flag scan. And here's the comparison, because if I receive an intraoral scan already screwed the scan flag on it, the whole emergency profile is covered by the scan flag. I have not anymore my emergency profile information. And all we know is we want to work professional, we want to make everything nice, hygienic, and all those things. But if I want to make it hygienic and I want to close the emergency profile, I need those informations. Well, if we are done with the intraoral scan, and this is our working base, it has to be accurate, and you're able to work in any kind of cases digitally. What I have for experience right now, also for full arches, it's not a problem at all when you know the protocol and when you know the steps in between. And one of those protocols or steps is now the registration process of the patient information itself. And you as a doctor and technician, you know that we work till now with a special device called FaceBow to register the unique maxillary position to transfer it in a articulator. It can be physical or virtual, doesn't matter. But the thing is, if I use those kind of FaceBows, I get not the same registration, or I'm not able to register the same position of the maxillar as the patient has there in their mouth. And you can see here immediately, we made three tests with 3 different FaceBows, and we don't have only differences in the sagittal axis, we have also differences in the horizontal axis. And now try you as a technician to do there an aesthetic and functional restoration onto it. Of those kind of informations. It's quite impossible. To understand that better, I have now here an example. You see immediately the middle picture is tilted for a few degrees. I will not tell you how, but you think, okay, maybe how much degree is that? And I will say to you, it's not a lot. And also just a few rotation of a small mistake during the registration with the FaceBow has a lot or huge effect on my restoration about aesthetic and functional. And as you can see, this picture is just tilted a half degree, and it seems a lot. And let's transfer this kind of mistake to a patient to patient situation. As you can see on the left side, the patient is looking to use straight, as a normal person would do when they're talking to you, all like this. And then to the right side is the registration with the FaceBow. You see immediately the posterior area is completely tilt upwards. And if I match now both pictures together, you will see it much better. And now, well, I have a wrong inclination in the posterior area, not really related to the original position, not really related to the function of the articulator. So I'm quite positive that the doctor has to or adjust the occlusion surface, mostly in the posterior area, by using those kind of mistakes. And let's think a little bit different. Let's think, okay, maybe we have a small mistake in the horizontal axis. And me, as a technician, has now the task to rebuild the tooth 1-1, like the incisor on the first quadrant, and to do a crown or whatever. And I use, as usual, the adjacent to the other incisor as a reference. So I make the same shape, the same length, and all those things. I invested a lot of time, a lot of love, obviously. And after that, I send it back to the doctor. And he wants to cement right now into the patient's mouth. What's happened? Because of this kind of mistake and rotation, the tooth, the rebuilded tooth, seems longer as the other incisor is because of the rotated axis. So the doctor has to adjust again the length. And that's why we thought we have to do something else. We have to create a workflow what is easy to use, what is able, or how you are able to reproduce any time and at any point the same position of the maxillar and transfer it into the articulator without any rotations or mistakes. This is the first point. So registration and transferring of the individual maxillary position. And the second feature of this kind of device and workflow is, and a lot of people, they don't know that, but this is essential in my opinion, is I'm able to restore the missing or wrong occlusion plane. But more later, we concentrate us now just for the transferring of the maxillar. As you know, we are able to just have also orientation like a Camper or Frankfurter, but we don't use those kind of references. We just transfer the only one position in our articulator without any kind of rotations. And how we can do that, we work with a reference called natural head position. Each patient can take their own natural individual posture and head position by looking themselves into a mirror. And by doing that, we are able to capture the unique head position, in the end, the maxillar position, and transfer it into the articulator. And our transferring device is not looking like the Facebook itself, but it's looking like that, as you can see on the picture. It's standing onto the floor, and we have attached at the top part a mirror. So we don't attach it onto the patient's head as we do with a Facebook. The patient is standing into the device, very relaxed, very free, and is looking themselves into the mirror. And after doing that, we are able to register this position. But before we do that, we have to be sure that the patient is able to align the head position at any time at the same position. And we have to control that, and we use a kind of a control angle. As you can see now here into the picture close to the patient's head, this kind of angle with the open space in between where you can put a pen through. The reason is we just mark onto the patient's face like a straight line or two dots along this control angle, and the patient goes out of the plane finder, goes inside again, and then the two dots or straight line has to be on the same level as we marked before. And then we are sure that the patient can align the head at any point at any time. And this is essential, and this is phenomenal, because to 98% of those kind of registration, the patient is able to reproduce the head position immediately. And that's amazing. So we can use this kind of device in a manual workflow, but this is not really my concern or my idea to explain to you, because the theme is to work digitally. That means I can use this kind of device also in a digital way. In the end, I have a digital face bow, and this is amazing. And to use it in a digital way, I have to use our 3D facial scanner called Face Hunter. The Face Hunter does not make just 3D facial scans. We are able to capture the unique head position by doing doing shots, photos. So we position the patient again into the plane finder. We mark the patient's head, we control the position and place the face hunter in front of the patient and face hunter and plane finder. As you can see on the plane finder, there are little dots, and those dots are scan markers we are able to use to transfer the head position into our software by clicking onto the mouse and doing just one shot. That's amazing. Now I have my natural head position in our scan software. And and then I have aligned everything correctly. And of course, the patient is aligned and placed into the articulator device in a correct position with just one click. And that's awesome. Obviously, I can make also 3D facial scans. You can see onto the right side, there's a kind of static scan, emotional-less situation. This is not really important for me. I need like emotional scans, smiling, or in a lip relaxed position, or well, mouth open, but it's a little bit overdose in my opinion. But I need those kind of emotional movements to have smile line information, aesthetic midline informations. I know exactly where the teeth has to be placed, and it can work into the patient's mouth to place virtual teeth in position, and I get directly a feedback how the patient would look with the new teeth, and that's amazing. A lot of people, they ask me, yeah, but how is the registration of intraoral scan into the 3D facial scan? How we bring now these two datas into each other or align to each other? We don't match it over the teeth or over the gum. That wouldn't be accurate enough. We use a special fork called digital transfer fork. And this fork has on the front scan markers as well, and onto the back a kind of plateau where you can squeeze silicone onto it. After that, the patient takes this fork into the mouth, bites very gentle onto it, and we make a facial scan of that situation. So we are not done right now. We take the fork out of the mouth and we have to rescan it with our desktop scanner, with our table scanner. We scan the whole scan marker surface and the impression of the upper teeth we got from the silicone. And now it's time to match those two pieces onto each other, and we are using the impressions of the upper teeth. So we just highlight the whole surface, we match everything onto each other, and now the software does use this package and align it to the facial scan with the fork, and we have exactly the same upper and lower jaw position as the patient has it naturally in their head. And this is amazing. It does exist a but, and now I have a little sugar, a little candy for you, as we would say in Germany. As you have seen right now, we need to rescan the whole fork with a table scanner. It makes a little bit, or it's a bit difficult when the doctor and the technicians are not really close to each other. Like I work with a lot of dentists in America and I'm based here in Italy. So it's quite uncomfortable to wait for the Italian post until the fork is arrived. All other data I will receive with email, but the only thing, the physical part is the fork, and I need it to continue to work with. But we are closed the digital circle by using this kind of green piece you can see now on your screen. And this green piece called cover. And this cover will be placed on a new type or new designed type of fork. It's a little bit shorter. And this fork can be still used in a conventional way by using the scan marker, or we can slide the cover onto it. And now it's time to use the whole fork digitally. That means the doctor is able to scan the whole fork with their intraoral scanner. And this is fantastic. So the doctor can provide all the data I need as a technician to continue to work digitally. So the workflow is similar. We just squeeze silicone again onto it. We make a 3D facial scan with the fork and the cover. We take the fork out of the mouth, and now it's time to scan it with the intraoral scanner. And this is quite easy because we start with the cover region. So we scan the whole area, go over the edge and scan the impression of the silicone, or we can let the fork into the patient's mouth and we scan just a little part of the teeth for our references. Here in this case, I use part of the teeth. That means I replace the fork into the patient's mouth. There are different ways to continue by using the matching workflow. You are very free to use any kind of workflow. So here you see, now we have to continue with the matching step. So we match fork scan onto the facial scan with fork and the intraoral scan onto the fork. And now we able to receive the same result, the maxillar and mandibular position in exactly the same, or in the same position as the patient have in their mouth. And now, after that kind of workflow and positioning into the articulator, we would be ready to start with the designing workflow. But there's one point, and it has to be clear for you. You can use, obviously, our virtual articulator, and a lot of people, they are doing that right now. But also, if you use the face hunter and plane system workflow to positioning into the articulator, we have still a average programmed articulator. And to do it more individual, I need information of the patient mouth movement or mandibular movement. And to receive those informations, I can use our plane analyzer. And this plane analyzer is, well, not just a diagnostic tool, because I can see after the movements in a specific protocol where maybe a problem is in the movement or a dysfunction into the condyles and so on. I'm able to record the movements, and I'm able to find the centric lower against upper jaw with this kind of tool as well. So we just explaining now the movement, because the other part will be take too much time to explain. The plane analyzer itself is split in two pieces. One part is attached at the patient's head, the other part attached at the lower jaw. Both parts are connected via ultrasonic together, and if you make the movement in the lower jaw, immediately I see the movements in real time in our software. And this plane analyzer device can be used together with a plane finder, our digital face bow. And this is phenomenal and great again, because I'm able to register the whole patient with their natural position into the plane analyzer device. Because you're able to attach the plane analyzer everywhere into the patient's head. You don't have references. To use a plane finder, we have references, and we have a good starting point to reproduce all those informations. So here again, a picture how it's placed on the patient's head, and the workflow is following. So we attach everything. Now we have a fork for the upper jaw to use in combination with the plane finder to register the whole patient in zero position, in natural head position into that device. Then we register that, and then we change the fork for the lower jaw, fix it onto the vestibulum of the teeth, and as you can see, in most of the cases, we have a lot of space to the upper teeth, no contact to the fork at all to make free movements. So now we do a protocol like lateral protrusion movements, left, right, protrusion, mouth open, and I'm able to see those kind of movements in real time in our software. So after those movements, I get a protocol, and this 2D protocol, the dentist is able to see all the dysfunctions, maybe to decide right now, hold on, it's not better to continue with those kind of recordings. We have to do a bite splint treatment to correct those issues. Or the movements are okay, and then the software is able to calculate for the Artex, Cavo, and SAM articulator, and especially for our Zirkonzahn PS1 articulator, special parameters to program the articulator regarding the movements I recorded before. In the end, with other words, I get a fully adjusted articulator by using those recordings. And this is amazing, but history. History in this way, we are a step further. In this way, we don't use the regular movements with a protocol and the transformed data into parameters. We use the original recordings, movements as a 3D data. That means I don't make these ordinary movements as you've seen before. What I need is mastication, chewing, for example, that I can record, save as a data, and transfer into our CAD software, especially in our latest CAD software called Modifier. There's the importation for free and quite easy. And here, after that, the 3D articulator will be not used anymore. We are using just the movements we recorded before. And this is amazing because now I'm able to place teeth regarding the movement, and I'm able to create individual occlusion patterns regarding those chewing movements, for example. Let's continue. I want just to show you the comparison between the normal tooth setup and cutting functions. So this is now tooth setup with a little intrusion to the antagonist. And as you know, if I use just the static cut function, then I have this kind of result. Well, in my opinion, is okay. It's fitting, but in the movements is not really good at all. Yeah. What we need is a dynamic movement by using the 3D articulator, for example. But I have to know how to program the articulator in their protrusion, lateral protrusion movements. When I'm not doing that, then I get this kind of straight cutting. But when I know how to program the articulator, then I have a better cutting dynamic surface. But now can we come to the real movements? Because I didn't import it till yet. After importing the real movements, I'm able to calculate a kind of summary of those kind of movements. And regarding the summary, I'm able to place teeth now in individual position. And that makes first better in the aesthetic because I have the movement, and I can able to cut the occlusion surface regarding the recording. And this is amazing. So when I have all those informations, or less, it's not a must to work with all those instruments, but it's the optimum. That's the high standard, I would say. Then we can continue with our designing. And we start every time with a provisional restoration. And this provisional restoration can be a PMMA provisional, occlusion retained onto implants, or onto teeth, or in that case, as you can see, in shape of an anatomic bite splint. What is an anatomic bite splint? In America, we would say snap-on smile. This is just a kind of bite splint with teeth shape. The patient can step it onto the non-prepped teeth. The reason we're doing that is we can use it as a try-in, as an aesthetic try-in or a functional try-in. Maybe the doctor is able to adjust the surface and so on and transfer those informations into the final restoration or a second provisional restoration. The other reason is when I have a patient like him, he is a bruxer and he lost a lot of tooth material, as you can see, and vertical dimension as well. It's not really clever to start with a final restoration. It's better to adapt the new vertical dimension, the new occlusion surface by using a really soft material in a shape of an anatomic bite splint. So what we're doing is we're capturing all the informations by using FaceHunter, intraoral scanner, plane finder, and maybe also the plane analyzer. And then we have all the informations to place teeth in aesthetic and functional position. And I have every time my facial scans to control the aesthetic. I have a feedback how the patient can look with those new teeth. Placing them, we're designing them, we are adapting them onto the non-prepped teeth model. And then we are ready to mill this snap-on smile out. For example, here in our multi-stratum flexible material, that's a polycarbonate material. It's a little bit flexible. It's a multi-layered polycarbonate, and it's milled till 0.1 millimeter thin. So it's only certain areas, not everywhere, but it's stable enough also to have certain areas 0.1. And yes, we are able to mill till 0.1 millimeters. This kind of snap-on smile is made with our modifier software. The modifier is amazing by using that. It's a very guided step-by-step workflow, very easy to use, and the fitting is amazing. So we did this for the upper and lower jaw, and now it's time for try in into the patient's mouth. And you see everything fits perfectly without prepping the teeth as usual. A little bit of surface texture and polishing by hand. You can use also glaze material, but now the patient is able to wear that for a few weeks to adapt the new vertical dimension. And yes, the patient is able to chew or to eat with this kind of step-on smile as well. Look at that, kind of phenomenal result. Patient is happy. And I think you agree also it is a kind of marketing instrument as well to convince the patient doing this whole treatment. Okay, let's go to a case I did with a doctor from America together with Dr. Holger Meiser. He's German as well, but he lives since years in USA, and I worked with him to do some cases to try out new stuff into patients' mouth, materials, components, and all those things. And this is one of the cases we did. And as you can see, well, the patient has or had several treatments in the upper jaw with the natural teeth, like root canal treatments. In the lower jaw, you see we have placed implants, but a huge bone reduction. So we couldn't use natural teeth as a fundament, and also the implants neither. So that's why we said we have to extract everything and start from the scratch. That means we have to plan the implants, we have to place the teeth again, and so on. And we thought to follow a new workflow. First, by using FaceHunter plane system to provide a provisional restoration, but by using Implant Planner with an immediate workflow protocol. And that's what I wanted to show you right now. So, but in the end, to having this kind of result here. This is the final product in the patient's mouth. So the starting point is, after the first appointment from the doctor, he makes the facial scans, intraoral scans, and he sent me everything to the lab, and I make the analysis for myself. I know I have to make new teeth placements, and usually as a technician, I use the pre-op situation as an orientation how to place teeth in position. But then I recognize and I've seen, oh, there is, well, I cannot use the situation because everything is hanging down. It's not aesthetic. The occlusion is off, and so on. I need to have other informations, other references to making a functional and, of course, aesthetic tooth setup. And for that, I'm using the second feature, the second function of the plane system to restore, to reproduce the occlusion plane. So by doing that, I have to measure something onto the patient's head. But slowly, we start with a part we know from the university or from the school. We know that the occlusion plane is nearly parallel to the camber plane, or in contrario, like the camber plane is parallel to the occlusion plane. That means if I would have the information of the camber plane, I could reproduce the occlusion plane. The thing is, camber plane is measured onto the skull, so I'm not able to cut the skin away. So what we're doing instead, we measure onto this skin. We're using the same dots, the same references as camber, but the plane in the end called alatragus plane because measured onto the skin. And if I have this kind of information, angulation of the alatragus plane, I do it onto the left and the right facial side, obviously, then I can reproduce the occlusion plane. We could do that manually, we could do that also virtually. So this is just a picture by marking the patient's face. And after the measuring, we got different results, not just different results for each patient, obvious, yeah, different results on each facial side, because we as a human, as a patient, we are asymmetric. It means onto the left side, we have a different result, and onto the right side, we have a different angulation. With this kind of specific and individual angulation, we're able to reproduce a occlusion plane in a virtual shape. And this virtual occlusion plane is also cut in the middle, so I can angulate both parts, both wings, after I measured or regarding to the measuring I did on the patient's face. So, and also, as you can see onto the plane or to the plate, we have some circle indications. This is the tooth placement information. So I know exactly where the molar has to be placed, the incisors have to be placed, and the premolar. And regarding, as I told you at the beginning, it's better to scan with the intraoral scan or do with a physical impression. An impression or scan of the tuber region, hamular notch region, because then we're able to measure in a specific workflow the distance to the first molar where the musculatory center is, to build up from this point a stable, functional and aesthetic tooth setup. So when I reproduced the occlusion plane and I placed it between the upper and lower intraoral scan, I see immediately the previous situation is completely off. Yeah, the incisors are way too much up, so I have to bring them down. The posterior areas are hanging because of the elongation and so on. And then I rip everything off because I don't need the pre-op situation anymore, and I do just a tooth setup onto that new virtual occlusion plane. So look at that. It is quite easy to do that because I have these circles as indications to place teeth in a correct position. So this is now made with a Mandible software, our basic cut software. Everything is aligned very well. But the thing is, I made the tooth setup manually onto this plate. When we go now a step further and using the modifier software, our latest cut software from Zirkonzahn, here we are able to use this kind of plate as well. The difference is the modifier software can make an automatic tooth setup regarding to this plate with just one click. You see, after loading the jaws and the plate and reloading the teeth will be placed first in a generic position between upper and lower jaw. And as soon as I activate or give this software the information, please use the plate, the teeth are jumping automatically in position where I need them. Obviously, I can make afterwards any kind of modifications. I can use my facial scans to make some modifications, as you can see here now in the video. I have directly a feedback how the patient can look. I can work them into the patient's mouth. And what is amazing as well, because till now we just had 3D facial scans, yes, but only static facial scans. With a new algorithm here into the modifier software, we are able to program an animation, a facial scan animation between 2 or more facial scans. This is amazing. Yeah, it seems like the patient is moving their mouth in real time. And this is now back with to our this kind of patient case with the doctor from America. You see, the tool setup is made, then the designing of the gingiva. I can zoom inside. I can work immediately to into the patient's mouth. I see the distance to the lip, and so on. And this is fantastic, fantastic. And now we come to a new feature I will show you. Well, gingiva design is a part of our daily work. To do it a very natural shape is quite difficult, and it's very time consuming. I think you agree, all of you. What we did with the modifier is we integrated a automatic gingiva design. After the tooth setup, you are able to create or activate a gingiva, and a pre-shaped gingiva will be adapted onto the tooth placement by just one click. Till now we have 3 different shapes. Not only the outer surface is nice shaped with a nice texture, also the inside with a palate or the lingual part as well. So in the end, with other words, I'm able to create gingiva with just one click. Look at that, isn't it beautiful? So that I can save out, and I can adapt on implants, for example, like in this case, just adapt it, make the basal area nice round shaped, and so on. Now we come to the backward planning. Well, the tooth setup is a part of the backward planning because I need the tooth placement to know aesthetically and functionally where I have to place the implants. So I can do the whole workflow as I explained you before and using the implant planner afterwards. What's the recommended workflow? Our implant planner software, it's a built planner software from Zirkonzahn. It's an open software. You are able to import any kind of data, like intraoral scans, model scans, wax ups, and so on. Like here, we have a model scan where we matched onto a lower jaw because we want to plan implants in a lower jaw. And we are able to cut unnecessary DICOM data away. And if you have those kind of artifacts looking through the model surface, we are able to cut the DICOM data onto the model surface away to have a nice, clean working base. After that, you just import any kind of other necessary data like upper jaw, facial scans, tooth setups, and so on. And with a special algorithm, you don't need to match them again. You just import them, and they are in a perfect position, a perfect relation onto each other. And after I imported the facial scan, as you can see, I align also the X-ray onto the natural head position as I registered before. Especially for the lower jaw, we have to create a panorama view to detect the mandible nerve channel, to place in that nerve channel a digital nerve. But I think you know this protocol, this workflow, to not place the implant too close to the nerve to damage maybe. If you made a tooth setup previously in our CAD software, you can import it immediately. If it's just a single tooth, you can use our quick tooth setup tool implemented in the implant planner software to place teeth very quick in position. And after that position, you are able to place finally the implants. We have a huge library. This is just a few. You have to download it manually. We have not just the implant components, we have also the prosthetic components like the parallel, the conical, or multi-unit abutments. And we have different heights and so on to use them, to place them in the correct position, to plan everything beforehand. Yes, and of course, you can choose from a huge library also sleeves, drill sleeves, or you can implement your own sleeve parameters to create your individual sleeves if you don't find them in our library. And the other benefit is I'm able to continue afterwards immediately to create a surgery guide. It's implemented in that software. It's a guided workflow as well. So we block out all the undercuts to get a better fitting of the guide itself. We are able to adjust the surface by using the add and remove a material tool, and then we just draw a margin around the implant area or those area where the surgery guide has to be fixed. Yes, we can also add pins for edentulous patients to fix them, to fix those guides with the pins as well. Not a problem at all. And modifications of the guide is very handy as well by using the add and remove tool. Afterwards, the guide will be ready to cut out some windows. We have different shapes. You can decide the size and so on to get a kind of fabrication window to check the fitting onto the patient's situation. Teeth. We are a friend of milling, so all the guides we do for our patients, we mill them. It's phenomenal. It's very accurate, and of course, if you don't want to mill them, the Implant Planner software is, as I told you, an open software. You are able to export the guide as an STL format and to print this in the end. So, and now we come to a special part we will implement in the future in our Implant Planner as well. Not just doing this kind of basic guide, we are able also to do in the future a stackable guide, a two-component guide. That means the base guide, like on the left side you can see, it's a positioning guide and a bone reduction guide at the same time. And if you place it onto the situation, the doctor has a guide to reduce the bone. If it's ready, he places now the other part onto it to drill the pilot holes into the bone. And what we can do as well with the Implant Planner, after the planning, we can activate scan flags. And the scan flags, as you know, are made to detect the implant positions. And we're doing that digitally as well. So that means after planning, we export the scan flags and we import them into our CAD software. And here you are able to design immediately your provisional restoration crown. Or if you're clever, you do something else, because we have the placement of the implant. We have the tooth shape. Why not creating a individual, or with other words, a custom healing cap? So we are able to draw a margin around the cervical area of the tooth. By using our abutment module, we are able to shape the profile underneath in the Talpi shape. And then we are ready with the with the custom healing cap. This can be milled in, here's an example, in our PEEK material called Technomate Mineral Tissue Color, or if you want, you can mill it also in a titanium material. So now the last minutes, we come to the immediate loading workflow, only a few words about that. And we have a special workflow, and this is unique worldwide. No other company can do that or provide that. And this kind of immediate workflow called double milling. So the words are saying already, double milling, I mill something twice, but it's separated in upper and lower part. I will explain you. First of all, we start with our tooth placement with gingiva, obviously. And then we can merge everything together. And this kind of merged piece without any implant informations, we're able already to transfer into our nesting software. In our nesting software, we are able to calculate just the upper part of the restoration. And this is almost 80% of the whole restoration. And obviously, it takes a lot of time to mill that, up to 2 hours, 2.5 hours, depending on the quality. The lower part will be not touched at all because we don't have implant informations right now. So what we're doing, we mill that until the date of the surgery is, and the doctor place the implants freely, manually, into the bone, or you can use also the guide. It does not matter at all, but it matters afterwards to capture the implant position by using different workflows. Yeah, the impression copings by using impression, physical impressions, or scan flags within a digital workflow. It does not matter. But in the end, via a matching protocol, I bring now implant implant model to the previous pre-op model, match everything together, and what I do is just I'm adapting the already made tooth setup onto the fresh placed implants. I have a perfect gingiva profile and so on. I adapt everything underneath, make it a little bit better with cleaning channels maybe, and I do non-modifications onto the top part because it's already milled. Now I transfer that final product back into the nesting software via an automatic matching protocol in the nesting software. We align the new adapted situation onto the already nested situation, and then we just calculate the bottom part with the basal gingiva profile, the implant interfaces, and screw channels. And this kind of resolution or this result needs a certain time to mill. It's depending onto the implants, or how many implants I have. Usually 4 implants need half an hour up to 45 minutes to mill the bottom part. But I think this is quite a reasonable time. It's not that much. But the benefit is I have a complete digital created immediate loading without any kind of conventional conversion into the patient's mouth with blood, with resin, and all those things. This restoration will fit onto the implants perfect. What you can do is you make a nice veneering, a nice layering with our composite material or others to create a restoration or final product like that. Yes, and the final restoration, I want to protect the patient a bit, but I made this picture after placing into the patient's mouth and aligned the digital situation and the analog or the real situation onto each other, and we have a perfect matching. The doctor had not to grind the occlusion surfaces or whatever. It was fitting perfectly. And the final restoration was just a screw retained upper and a friction retained lower restoration in this case. And the last few minutes we talk about the whole protocol, the workflow to go back or to go back to the analog from the digital work. Because a lot of people, they want to control the final product in their physical articulator, the occlusion surface. Then maybe they have to add porcelain and so on. So I need the same model situation and I need the same position of the models into the physical articulator as I have digitally. And for that, we have to first create from the intraoral scan a millable or printable model by using our model maker module. So here we can create also implant models with our scan analogs, implant analogs in it, and also in combination with removable dies as well. This kind of models are able to print or mill. It does not matter at all. But I have to say, we're still a friend of milling, obviously. Yeah. So now we can transfer the model position into the analog articulator. We are using a special transferring device or pattern, and this kind of pattern is called our jaw positioner. This jaw positioner is just a piece of plastic with 3 plateaus on it. And this kind of jaw positioner does exist virtually as well in our scan software. That means after placing, mounting the model pair into the articulator digitally, and we want to transfer this position into our analog articulator, we align by using the jaw positioner and the articulator table onto the upper jaw or any kind of upper jaw information, can be also the final restoration. And the intrusion of this upper jaw in this kind of plateaus will be cutted out. And as you can see onto the screen right now, we create in the end impressions. And this kind of impressions will be milled out with our milling machine. That means I take a special support, a special holder for this jaw positioner, place it into our milling machine, and I mill the same intersections, impressions out as I got or received digitally. And afterwards, I take this jaw positioner out, place it onto the articulator table. Onto this table, I will place the milled or printed model, and I fix it with plaster in a conventional way onto the upper socket. And the lower jaw has to be placed in the correct position by using a transferring, like a bite registration. You can do that with the bite splint module, or maybe the doctor has sent to you a silicone bite reg, and you can use that to bring the lower jaw in position. Well, this is the whole digital workflow from Zirkonzahn. Obviously, this is just an overview. There's a lot of more things to explain. I can talk like 8 hours in a row about that. It's very interesting. Yeah, I hope you enjoyed this kind of webinar.